The need to maximize agricultural output with minimum input is increasingly critical for food security. The current method of fertilizer application results in up to 70% wastage, which drastically degrades the soil, pollutes water, and yet does not improve productivity. India spends close to 88,000 crore rupees on fertilizer subsidies annually, and this is a huge concern for the government. A lot of hope is pinned on this technology that deals with the precision application of fertilizer through a powered urea deep placement or UDP applicator that is integrated with soil testing. It promises to reduce fertilizer consumption by up to 40% and increase food production by 25%. We bring you the story of US-India collaboration from San Francisco in the United States and the city of Lucknow in India. The team at Indo.org, working with Distinct Horizon Private Limited, led by IUSSTF, have turned the conventional way of urea application on its head by innovating a machine that places urea deeper into the ground, saving tons of urea from being wasted. The conventional method of application of urea is broadcasting the chemical.
What happens is, because it's lying on top, it oxidizes, it converts into multiple forms of gases, so it gets evaporated. On the other hand, it also runs away with the water and it leaches into the groundwater as well. So all these forms of losses finally lead to a very high percentage of urea getting lost to the environment. Now this can be up to 70%. And that's where we are also polluting a lot of the environment in terms of global warming, ozone layer depletion, water pollution. All that is happening on a very large scale. Now, by deep placing the fertilizer, what we are doing, we are almost eliminating this evaporative losses of nitrous oxides.
And nitrous oxide is one of the biggest reasons for global warming and ozone depletion in particular. With nitrates being very mobile, it further complicates the problem.
Now, if we deep place the fertilizer, it does not get oxygen, so hence it does not get oxidized. It remains in the form of ammonium and it remains localized. So essentially it is not polluting the water bodies, neither is it polluting the atmosphere.
Ammonia is very slow release nitrogen form. The crop get it in whole crop cycle. So now the crop is more healthy and as well as the soil is more better, because in this whole process the microbial activities also happen. If we talk about the N losses, when this UDP is done, the N losses is very negligible, it's around 4%, but when we do the broadcast it's around 35%.
Distinct Horizon claims that one applicator over its lifetime of 10 years reduces 220 metric tons of carbon dioxide equivalents.
Compare this to a solar panel setup of 1.5 lakhs. It is of 1.5 kilowatt power. Essentially that reduces 44 metric tons of CO2 equivalents over a period of 25 years.
That means in just 40% of the time, the applicator is able to reduce 5 times more carbon. With very few machines in the entire agricultural world that work successfully in wetland paddy conditions, which also leave the soil completely flat, this machine not only does a smooth job, but conveniently places urea briquettes deep under the field. Apart from wet conditions, this urea applicator is also capable of handling varying soil textures in fields with very thick soil. Designing a machine that accommodated this range was quite a journey for both the Indian as well as the US partners.
So the main method that we have used to design this machine for such tough conditions was rapid prototyping. So essentially we worked very closely with the Indo.org team, who taught us how you can do rapid prototyping using design thinking processes, which helped us to reduce the time frame required to innovate and design such a machine. So now that our technology has been strongly approved by the farmers, we want other bodies who are reputed in this area of agriculture to also validate the results that we are getting with farmers.
That is essentially where Distinct Horizons started working with Dr. Reddy's Foundation, Syngenta Foundation, and others who are now validating what has been done by the team.
So finally, our target is to take this to 1 million farmers by the end of 2023.
लेकिन फसल भी तो ज़्यादा हो रही है, वहाँ पे मुझे बेनिफिट मिल रहा है। मान लीजिए अगर ये नहीं डालते हैं तो तकरीबन हम लोग 1 एकड़ में 20, 21, 22 होता था, इससे जो है 27, 28 क्विंटल प्रति एकड़ हो रहा है।
मेन बात तो ये है मशीन से कि जब लेबरों से डलाते थे तो कम से कम 1 एकड़ में 200 पौधा हमारे नष्ट हो जाते थे पैर से, वो हमारे 200 पौधा बचे गए।
और सबसे पहला ये रिजल्ट अच्छा रहता है कि उनको कम यूरिया डालनी पड़ती है। एक बार डलवा दिए ठीक है, 15 केजी पर बीघे के हिसाब से एक बार डलवा देते हैं। वैसे क्या है, हम लोग जब हाथ से डालते हैं तो तकरीबन 1.5 कुंटल मतलब 1.5